I guess. I'll let you out a little early because I gotta leave town after this. So 6-2 is not too bad. It's all about the definitions of cosine, sine, etc. based off the triangle. So hopefully you remember this. And if not, let's talk about it now. So the mnemonic to remember this is so being sine equal to opposite over hypotenuse. That's where the OH comes from. Of course, I'm not going to force you to memorize it, but this helps you remember it. Co being adjacent hypotenuse, tangent opposite adjacent. So that's where these three come from. And I believe we've already mentioned when I gave you all those formulas that these three here are the reciprocals of the original three. The reciprocal of sine is cosecant, so just flip it over. Reciprocal of cosine is secant, just flip that over. And same thing with cotangent. So when I ask you to find all six, all you really need is three of them, and then you can just take your reciprocals. Okay. And remember that all these functions are. Well, I guess when I say opposite, etc., it depends on where theta is or what theta you are talking about. So it's relative to your theta. So sine of this particular theta, opposite is over here. If I had another angle over here, opposite would be down here. Does that make sense? So I mean, usually I'm gonna write it like this, but you don't have to. Like, you could have a question where it's like, you know what? Define it based on a different angle somewhere else. Okay. We were going to be doing more right triangles in this section. So this is a right angle here. So we wouldn't put a theta there because that's 90 degrees. Okay. All right. So I would keep these handy for exam, etc. So the first few questions in your homework are pretty chill. It'll just say find the six trig functions relative to some triangle. Find the six trig functions. So the first few will actually give you the triangle, then later you got to solve missing pieces. So here's a triangle. Theta is going to be there. So here's 3, 4, 5, the magic triangle. One of the magic ones. So define using these formulas here, or the definitions, list all six. That's it. Yep. So sine theta is opposites over hypotenuse. Right. 3 over 5. Cosine is adjacent over hypotenuse. Tangent is opposite over opposite over adjacent. And then use the reciprocals to find the other three. The reciprocal of sine will be cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. Any questions on how we did number one? So the first few will be pretty straightforward like this, nothing crazy. And then it'll move on to stuff like, well, they'll give you one trig function, and you have to build a triangle yourself. Okay. Yes. Oh, wait a second. You go to school in this stage? Okay. No rush. All right. Example 2 is going to be the same thing. It's just instead of giving you a triangle, you have to make it yourself. Find all trig functions. Given that cosine is 3/4. So that's all you're given to build a triangle yourself. So remember that the cosine is adjacent over hypotenuse, right? So we got those two pieces. So adjacent hypotenuse. So just find the missing piece using your Pythagorean theorem, because this is a right triangle. You can only use this for right triangles. So I'm going to choose to call this A. It doesn't matter which one you choose. We're just missing one of the sides. Plug in your hypotenuse. Solve for B. That'll be 16 minus 9. Square root both sides, and we get square root of 7, right? I'm sure you remember doing this at some point, right? So you may have to do this once in a while. Find a missing piece. Once you have all three pieces, it'll be exactly like example 1. Just write them all down. So sine theta is opposite over hypotenuse. Cosine was given to us. That's cool. Tangent will be opposite over adjacent. Right? So now I just find the reciprocals, and that's it. So reciprocal of sine is cosecant. Now there is an extra step here. If you notice, you get square root on the bottom. Technically, that's correct, but we're supposed to give rid of square roots just because it's proper notation. Multiply top and bottom by √7 in order to rationalize. That would give us 4 √7 over 7. Secant. Just flip it over 4/3.
Is it okay if I don't factor the 4 times the √7?
Which I'm saying one more time.
Is it okay if I don't factor it, like if I just put the square root of 28?
28. You mean What do you mean, like not like? Why would it be 28? I guess. Like here?
Because isn't the 4 times the square root of 7 20 the square root of 20?
No, only if it was square root 4.
Like,
Like you can only multiply if they're the same time. Like this would be cool. But if it's a 4 root 7, you would have to first bring it in as a square, which would actually be 16 times 7.
right.
But that would not be reduced anymore. So just leave it like that in front. Down here, though, you would be right. 7 times 7 is 49. Put square roots to 7. Okay, so this is like the proper answer. If you left it like this, I mean, I'm probably not going to take points away, but this answer versus this answer is like using proper commas and punctuation in English, right? That's the difference. I mean, if you write it like this, I know what you're saying, but if you write it like this, you're writing more properly. That makes sense? Some people would mark it wrong. I think it's fine. You speak in broken math. Sometimes. I'm sure you'll get better over time. Any questions on example 2? Oh, yeah, I forgot cotan, right? Flip that guy over. You rationalize, you should get this guy. So the first question will be just pretty basic, and then they'll move on to stuff like this where they'll be missing. Yes.
So, okay, so cotan, those secant, you extra work for, and the rest of them is just what it is.
You have extra work if you end up with a square root on the bottom. So whenever that happens, it doesn't have to be those two. So whenever that happens. So this had a root on the top, the reciprocal took it to the bottom, which creates the extra work. So after doing these types of questions, we'll move on. The homework will start to move on to, well, they'll give you triangles, they'll give you hints when you find the other pieces, and then it moves to word problems. So let's go ahead and do word problems. Those are harder. So I'll do a couple of those instead of these types. Do you have any other questions on a question like this? Right, do you see if you're given one of the trig functions, you can build a triangle as long as you have one trig function. Doesn't matter which one they give you, you can always find the other pieces. Right? You guys cool on this? Yeah. Let's do some word problems. Example 3. So find the height of the tree. A giant redwood casts a shadow by 132 feet long. Find the height of the tree of the tree. Yeah, where is this? if the angle of elevation to the sun is 25.7 degrees. All right, so whenever they say elevation, that's the angle when you look up towards something, that angle formed down here. That's the angle. Okay. So I'm gonna draw you a picture. It will not be a nice picture, it will be a picture. Here's a sun here. Put a happy little tree there. My redwood. Okay, now it casts a shadow. So we'll say the shadow's over here. Okay, so I'm looking towards the sun. That's the elevation angle. So towards the sun. Right, because the shadow, the sun has to be behind the tree to cast a shadow. So that's why I drew it this way. That makes sense? Because they're not going to give you a picture, or at least I'm not going to. You need to read it many times until you figure out what is the visual. That's the hard part, trying to see what the heck you're talking about. But the solving part won't be too bad once you have it. They give you a picture, that's great. A little bit less thinking. So there's the elevation angle. You want me to figure out. So basically, you create your own triangle and find a missing side, just like we did example 1 and 2, but it's applied to something real. So this is my height. So the next hard part would be, once you've set it up, is choosing the correct trig function to help you out. Okay. So we're missing, so here's theta, right? So which side is missing relative to this angle? Or what side are we interested in? We have adjacent, right? So yeah, we need to find the opposite. So choose a trig function that incorporates opposite and adjacent, because that's what you have. So that way we have only one unknown. Yeah, tan and cotan would be the ones you want to use. Because tangent, I'm going to choose tangent just because it's equal to opposite over adjacent, right? Which in this case would be, in this case, tangent of 25.7 would equal the height, h, over the adjacent, 532. You see how we set this up? That makes sense? Or, right? Tangent is defined to be opposite over adjacent. I picked this as the theta, so opposite to this over adjacent. Tangent of that. So just solve for h, and you'll know the line. So at this point, you're going to have a scientific calculator for this chapter. You're going to have to use one. Okay. So solve for h, we'll get this here. 532 feet times tangent 25.7. So calculator says that something.
So 256.03.
Make sure that we're in degrees, right? Double check yourself. You could probably write. I don't remember. But always double check before you write that down, right? Am I in degrees? Yes. Does this seem reasonable? 256 feet for a redwood tree? They're pretty huge, right? You guys got them Woods or San Francisco? These trees are awesome. 256.03. Okay. Any questions on the approach? Any questions on how we built the picture, the visual? Does that make sense? Okay. So in this section, they're all going to be right triangles, so it should be doable. Then later we'll get into triangles that are weird, where we have to use more complicated formulas. But these will always be in the background. Do one more, and then we'll move to the next section. You guys cool on this page?
We don't have to do the rest of them. Final one.
I mean, we could, but all they wanted to know was how tall the tree was. So the height, finding the opposite side would be the height of the tree. So this is but yeah, we did create a triangle, so we could find all the trig functions. We could find all the sides. That is doable. Should be. But you know, I'm not gonna do what the ants because I'm lazy. Here you go. Did this one earlier, example 4. That was a pretty cool question. It's another high problem, but it's a little more complicated. So from a point on the ground 500 feet from the base of a building. So on the ground 500 feet from the base of a building, and an observer finds that the angle of elevation to the top of the building angle of elevation the top of the building is 24 degrees. And the angle of elevation, to the top of the flagpole on the building is 27 degrees. Okay. Find the height of the flagpole. It was pretty useful, so you don't need to climb on top of a skyscraper to figure out how tall the flagpole is. Yes.
Is it to the ground or to the top of the sky?
So there's an observer on the ground, 500 feet from the building. He looks up to the top of the building, 24 degrees. Looks up again, the top of the flagpole on the building, 27 degrees. So that's what's happening. So let's draw that out. Any So observer finds that angle of elevation to the top of the building is 24 degrees, and the angle of elevation to the top of the flagpole on the building is 27. Find the height of the flagpole. Okay, so let's draw this up. Let's say you're down here just hanging out, and you're just really curious, like, how big is that flagpole? Really want to know. But there's no way you're going to climb the building and measure yourself, right? That's crazy. I'm gonna build some windows right here. Really nice building. Got this flag up here. Okay, so you stare at the top of the building. Let's say it's right here, and you create an angle of elevation to B. They said 24, right? You look up the top, 24. Then you look again, but this time at the top of the flag, 27. So since I'm in the same spot and the flag is only slightly bigger than the building, it makes sense that the angle is only a little bit bigger, right? I'm only looking a little higher relative to this point. Does that make sense? Okay. So I think this picture makes sense based on this information. And this guy is standing 500 feet away. Now we can figure out height of the building. So just call this guy H, height of the building. Let's call the total of, I guess, capital T. I don't know. This is a little more involved, but it looks like it's going to be tangent again because we're looking for that opposite side, right? So basically we have two triangles to create two different tangents. I should be able to find the total height, building plus flag, and just the building, no problem. So when I find both of them, I can subtract and find the flag height, right? So that's what we're going to do. So tangent of 24 is equal to H over this guy. So this height opposite over adjacent. Okay. Tangent of 27 will be this opposite, or all the way up to here, over 500. Does that setup make sense? How we built the tangent. Remember, the hard part is visualizing this, and then choosing the correct trig function, right? You have to decide, am I using a tangent or a cosine? But 90% of the time, if I'm looking for a height or an opposite side, you're probably going to use tangent. Okay. If they would have asked for like distance, I mean, tangent still would have worked, but you might have gotten away with a different one. One might have been a little easier. Anyway, let's solve for height. We're going to get 500 feet times tangent. Solve for H. Capital T is 500 times tangent. So calculator says that this is something. Yeah, it's usually, oh, that's really. Two 22.61, 254.76 feet. And that makes sense. This should be bigger. And 254 feet for a building doesn't sound insane. It depends what kind of building. Doesn't sound too small or ridiculously large. So flag is going to be the T minus the H, right? That will be something. Yeah, sounds right. Yeah. 1 4 round to 5. That's the flag. Any questions on the approach? Is it okay? Okay. That's it for 6.2.
Is it 58 at the end?
Yes. Yeah, 53, 57, 58. These are just some word problems. These are just practicing solving triangles. Yes, cool on this page. My 6.3 is, I'm going to cut it really short because it's stuff we've already talked about. It just said to rehash it because it's useful. The trigonometric functions of angles. So they go over reference angle again, which we will do one example and move on because we've done it already. But here's the definition, just in case I don't remember if we defined it. Trigonometric functions of angles. This is the reference angle definition. Let theta be an angle in standard position. The reference angle theta bar associated with theta is the acute angle formed by the terminal side of theta and the x-axis. So, which we've talked about already. So where the angle stops, how far are you from the x-axis? That's what reference angle was, right? You got a test question on that, guys. So I'm hoping almost everybody got it. Formed by the terminal side of theta and the x-axis. So if you're going around and you stop somewhere, that acute angle, or in other words, the distance between the x-axis and the terminal side. finding the reference angle. Which again, we've done, but the book wants to talk about it one more time. So 5/3, that's in quadrant 4, right? So they want the reference angle.
2 pi minus 5 pi over 3.
Yeah, do 2 pi minus 5 pi over 3. Common denominator will give us 6 pi over 3 minus 5 pi over 3, which is a single pi fixed. This is theta bar, reference angle. Part B is almost exactly like your test question. Almost. If theta is 870, you first have to figure out what the terminal angle is and then give the reference. So this is bigger than 360.
Minus 360.
And for sure, minus 360. This is actually what, 2 circles, so this minus 720. That will be 150. So this angle right here is coterminal to 870. This is the, I think we call it terminal point or terminal angle in chapter 5. But this is now a coterminal angle of 870 is 150. 150 is in quadrant 2. How far is it away from the x-axis? Right, so hitting 180 would be the x-axis, so it's 30 more, right? And if you can't see it, then you need to pull out the circle.
That theta you drawing, is that mean theta? Is that what you mean by the line? on top?
Yeah, that's like a little bar. So in the book, they call that the reference angle of theta. But yeah,
I can say we can use the rule pi minus the angle that we chose, like 150, and pi is already 180.
yeah, you can do 180 minus 150. That'd be the appropriate way. If you look at the circle, it should be pretty clear what it is. I hope. Anyway, the only reason I bring it up is for questions like this. I guess we'll do it on the next page. Yes.
Why did they use the
It's because of this. What is this? Someone forgot to log out. Let's find a random circle. This is the one I printed for you guys. Wikipedia. Okay, so 150 lands you right here, right? So the distance from here to the x-axis is 30 degrees. So that's the definition. It's the acute angle formed between the terminal side, which is where you landed, and the x-axis. That was the official definition. Earlier we had 5 pi-3, right? So that distance from here to here is pi over 3 or 60 degrees. So you can do the rule and just subtract from 2 pi, or you can just see it visually and say, okay, kind of measure myself. Right? Whatever you want to do. You guys cool on this page? This is the last example, and then we'll call it a day. Let me pass your test back to after this. Using reference angles to evaluate the trig function. So if you have a angle that's a little large and you figure, you know what, I'd rather just deal with the first quadrant. I don't want to think about anything else. You can always adjust and use the reference angle, but 240, the y is negative there, right? 240 is here. So the sine of 240 is this negative y value. So if I were to use the reference angle, which is a distance of 60 degrees, I would have to keep it negative because sine of 60 is a positive root 3 over 2. That makes sense? So this is where we're going with this to show you. So they're saying that you can always set this equal to the coterminal, just take into account the sine. So the coterminal angle, this one, I'm sorry, reference angle, of 240 is 60 degrees. I need to add the sine because sine is negative at 240. So I don't know how useful this is, but you can use a reference angle instead of the given angle. Well, you have to adjust for the sine. Okay. Can't think of a moment where I would use this myself. I'm trying to think of one. Maybe in statics or something. Maybe. Anyway.
It's not weird because sine is.
Negative. Yeah, that's weird. On this guy, this is already too big, right? Bigger than 360. So first adjust for it. And then think about, so adjust for the coterminal angle. Minus 360 would be, yeah. So this would be coterminal, I'm sorry. So this is 135 is coterminal to 495. And we can adjust and use a negative cotan for the reference angle. Yes.
How exactly are you finding after like 135?
Yeah, so go to 135 and see how far are you from the x-axis. It's going to be 45 degrees. So right here, 135 is there. So the distance from here to here is 45 degrees. But since 135 has a cosine of a cotangent of, it's going to be negative because it's x over y, right? So you're going to have to tack on the minus if you're going to use cotan 45. Because over here, it's not negative. But you could always just use this one, right? So who cares? It's up to you. So negative, the x value is square root 2 over 2. Let me just write this down.
So even answer, correct?
Yeah, well, as long as you get it to this, is what matters, right? What matters can you get here? Cotan is defined to be x over y or cosine over sine. So just put the cosine value and the sine value. then you're good. So either way, it's gonna be -1 depending if you use this one or this one. Anyway, so I'm not gonna spend too much time on that. But it will help you, if you don't already understand reference, it'll make it sink in doing this homework. Okay. I'll keep it short though. All right, guys, let me pass back your homework or your exams. Is it Marion Hernandez? Lisa, Marion? Eric, Rich? Nayeli? Hello? Ariaga? Okay. So I gave everyone 10 points for number 6. If I forgot to give you 10 points, let me know. If I saw number 6, I did just plus 10 no matter what. But if someone didn't write number 6, I may have forgotten. I double checked, but there might be one guy that I forgot. Just double check. I don't want to. I'll have your points. Eric, what?
I didn't.
I'll look at it. Eric, what? Angela Lopez. Also, I added a 5-point curve, so I gave you 15 free points. So I'm hoping that helps. Fatima, Joshua, Moreno. Alex, T. Laura Elizabeth Morales. So on the canvas, you have 5 extra points. If I didn't add it, let me know. The should be there. Juan, Master Juan. Eric. David. Try to give everyone some 50 points on questions that made no sense. Philip Miller. Yeah, the issue is yeah. Let's check this out. Might have put it in. Mark Gomez. Schedule a Kenzie person. Last name is Ravi. Megan M. Megan, okay. Aya Gonzalez. Lauren Dahl. Daniela Montes. Jose Santos. Neil P. Carlos C. Isabel Ruiz. Juan Sakura. That one. Oscar Khan. That one. Is that right? Awesome. Megan Ho. Mary Hernandez. See? Might have the other one over here. Eric Fun. Down one. Oh. Lauren Apollo was not here. Mia P wasn't here. The Santos. parallel C and later. Good. See the explanation? Six.
Yeah,
Yeah.
the first five, like,
I'll just see. Yeah, sorry about that. Yeah, I knew that number 6 is gonna trip me up a little bit.
Yeah.
Well, that was my bad. I wrote the question wrong.